Hey everyone, I'm Kyle. I'm a solutions engineer at Dagger, and today we're going to be talking about building your own CI platform on Nomad. And so, before we dig into the actual demo side of things, let's kind of talk about what CI is, how things work, and most importantly, why are we doing this, right? So, first of all, we want to learn what a CI platform really does. So, behind the scenes, what are all the things going on? So, even if you're never going to actually do a project like this, if you're just using something like GitHub Actions or Circle CI or GitLab CI to run these tasks, you can understand better what's happening within those systems. Or maybe you actually want to build a custom platform for your organization. You can kind of see the approaches I took and maybe copy some of the lessons learned. And then third, it could be fun. Spoiler alert, I spend a ton of time thinking about CI, probably way too much for a sane person, but I think this is fun and maybe you will too. So, what does the CI platform really do? It really boils down to it's going to automatically validate our code changes and it's going to let us know when things go wrong, right? So, validation, if we expand on that a bit, we're talking about running tests and linting and code style checks and builds, maybe seeing preview environments, but all of these things so we can say, I made a change to the code and I need some process to validate that those changes are acceptable so that we can merge those changes into the core product. And then if those things don't pass, we need the system to have some way to tell me, hey, there's something wrong with those changes you made so that I can go ahead and correct those. Now, the components of a CI platform, before we actually start building our toy platform here, we want to kind of lay out all the pieces to see what things we need solutions for, right? So one is the VCS integration. So we need some way to tie into GitHub or GitLab or Bitbucket, wherever you're hosting your code. We need some way to tie into that so that we know when code changes happen. We need an event system so that when code changes do happen, that can trigger something to happen after that to actually to kick off this CI process. We need some compute to actually run these CI jobs, and we'll go into what a CI job even means in a little bit. We need some job orchestration, so some way to say, hey, we need to run a CI job. We have compute here. We need to put a job somewhere and make it run. And then once that job lands somewhere, it needs to run a pipeline of tasks, right? We need some tasks specific to our application that can say, this is how I run the tests, this is how we run the code checking, whatever we want to call CI for our application. We need some way to define that pipeline. And then status reporting. We need to, when that checking happens, we need to report back somewhere and say, hey, this passed or it failed, so that as a contributor, I can get that feedback, right? So for our toy CI platform that we're creating, I've already chosen the solution for all of these problems. So our VCS integration, or really our VCS in this case is GitHub. So our application lives on GitHub. I'm pushing code to GitHub, and that kicks off this whole chain of events. The event system, so the thing that says when a code change happens in GitHub, we want to fire something off somewhere. We're using GitHub webhooks. So I'll show you what that means in a minute, but really that's a system built inside GitHub to fire off an event when something happens on GitHub. The compute is my home lab, so it's literally running on a pile of computers down here on my floor. A little bit off screen, maybe you'll hear the fans going when we run some jobs. The job orchestration is going to happen in Nomad, as hinted at in the title of this talk. So Nomad is literally an orchestrator, right? So it can orchestrate lots of things, including containers, which is what we're going to be orchestrating in this demo for our CI platform. The pipeline execution engine, so the thing that says, in my application, this is how you run tests, and after you run the test, do this next thing. The engine that runs those pipelines and understands those pipelines is Dagger. And so the Dagger engine is this glowy yellow orb in the middle of the screen, and it can run pipelines in a lot of different environments, right? So it can run them in any different CI. I can run them on my machine. And those pipelines are defined in a programming language of my choice. So like Go, TypeScript, Python. And I can use modules from this ecosystem of other Dagger users. So we'll see what this pipeline looks like in a minute for our example application. And then for status reporting, when that pipeline runs, we want to see the pass or fail again. So that's going to happen in Dagger Cloud, and we'll see that happen once we actually run our CI in a few minutes. So to kind of go through the flow, once we've hooked all these components together, I'm going to make a change in my application. I'm going to git push, and that goes to GitHub. And GitHub is going to receive that new commit. And when GitHub receives the commit, it's going to, since I've configured a webhook, it's going to send a payload to a URL that I've defined. And I have a service listening at that endpoint. And it receives that payload that says, hey, there was a commit. This is the commit from this repo. This person pushed it at this time, and so on. Tons of information with that. And we can kind of pick apart what we need from that payload to then go ahead and dispatch a Nomad job. And then when we do that, Nomad is going to receive this thing that says, hey, we want to schedule a job with this information. And it's going to look across this cluster and say, there's some room right there. Let's put a job over here. And when that job starts running, the definition of that job is to run a Dagger task. And so Dagger will start running, and that's going to run our whole validation pipeline for our code change. And that validation is going to be reported on Dagger Cloud, so we can see from the outside what's happening within that pipeline and whether it passes or not. So, demo time. Before we get into the little CI platform that we built, let's talk about the application that we want to do the CI for, right? So we have this greetings API, this really cool production grade app that I have that is just a simple little API that returns a greeting. And there's also a front end component, so there's a cool front end website where you can see that greeting. And so with that application, let's look at it in our editor. We have our main.go, and that's like the web app. But the important thing is that this application is Daggerized, so that means that all of those things that we might want to do for developing and testing and deploying the application are all defined in Dagger pipelines. So if I expand, and I know it's hard to see this left side here, but within our application we have a .dagger directory. And within that there's this little main.go. And that's like my top level, like this is my application according to Dagger. Here's all the things you can do with it. And so skipping all like the gritty details, we have like a function here called check. And let's say this is our thing that does our thorough validation of a code change. And so this thing called check will run a function called lint, a function called test, and a function called build. So every time in CI when something happens and we call check, we want to lint, test, and build the application. And if all those things pass, then we're golden and we can call the change good. So if you look into one of the functions here, like test, for example, this function runs the test for the backend specifically. So I mentioned we have like a front end and back end component to our application. Those are also defined by their own Dagger modules. And so if you look at the back end unit test function, we're now in the back end package. Here's this function called unit test, and we're using a Golang base, adding our source into it, and calling test. And so Golang is a package from, it's a Dagger module from the Daggerverse, which is this collection of community modules. And this one is specifically for doing things with Go projects. So it has built-in functions to do things like test or Golang CI lint, and so on. So we've seen the code that defines my pipelines, but if I actually make a change to my application, like let's say on the front end, let's say here's a change for hashy talks. 2025. Thanks, Copilot. We can hop over to our terminal, and I've run Dagger functions here. So this will show me the Dagger functions available in my app. So we have like build, check, and so on, the ones we saw in code, right? So Dagger is translating these to CLI commands for me. And so we can call Dagger call check. So this is one of our functions. We can call it. And we can see like the description here. You might notice it's sourced from that. Let's see if we're in the right file here. It's sourced from this code comment. Run the CI checks for the project. So we can call that. And then Dagger is going to do all those things like the lint, test, and build. And so we'll see this happening in our terminal. It's going to pass in the source of my project from my current directory. And it's going to run these pipelines for the front end and back end to do like the linting testing. You can see it pulling containers, and it's orchestrating all these things all around. And so I'm running my whole CI before I even push to CI. So that way, with that dev feedback loop of like knowing is my change good or not, I can actually see this right here, the same thing that's going to happen in CI before I push it. But let's go ahead and push it anyway. So we saw it pass. Good. Now, hopefully, when we push the CI, we see the exact same thing, right? So if I say get status, okay, get add, and we're gonna give it a message like hello hashy docs. And then before we get pushed, let's look at our toy CI platform. So we talked about having things running on Nomad. So I've got a bunch of Nomad servers, and they all have a configuration that looks something like this. Now the only thing I want to highlight here is on the clients we've got Docker privilege enabled, Docker volumes enabled, and Docker caps allow this. So that means you can add capabilities. Jobs can have containers that have added capabilities to them. And so we'll talk about why that's important when we look at the actual jobs. So we've got a cluster out there. We can actually look at it over here where we've got 3 nodes, a varying amount of resources, and we can see they all have something allocated to them. And each of these is the Dagger engine. So if you remember this glowy circle thing, that's the Dagger engine, and we have that deployed on each of the nodes. So how did we get there? Let's look at this HashiTalk 2025 project, which I'll link on GitHub at the end of this so you can see it for yourself. We have a Dagger engine job, and this is a system job, which means, like we saw, it's going to run this task, whatever it is, and we'll see what it is in a second, on every single node in our cluster. And that's important because we want to have that engine available in the whole cluster right next to whatever job that gets placed, so it can point to its next door neighbor and say, here's where my jobs are running, and we don't have to find an engine somewhere out on the network. Anyway, the Dagger engine itself is running as a Docker container. Here's the engine. And it's privileged true because Dagger itself is a container runtime. Like we saw when we ran that pipeline locally, it's creating this whole workflow of orchestrating containers in different places and passing data from one to another and so on. And so it needs to be able to run containers, so it needs privileged and capabilities and all the magic things. But that's cool because this is the system task running on my cluster, but it's not actually the thing that's getting kicked off by GitHub to run the jobs. It's just this other thing on my cluster that the jobs can talk to. So because I've provisioned this for my CI cluster, I'm not as worried about running this as privileged because this isn't the thing that things are being dispatched to. This is just another service. Anyway, this has a couple of volumes. They're kind of implementation details of how things run and optimizations. And then we've told it that it has a bunch of memory so that as our jobs start running, it doesn't kill the engine because our job's trying to run. This is where the real work is happening. So I've talked a lot about this engine, but I keep mentioning this job that happens, right? So let's talk about the Dagger job. And so this is a parameterized batch job. So that means that we actually kick this off when a new Git push comes in. And we kick it off with some parameters like repository and commit. And also our cloud token. Because again, we want to see that the status happening on Dagger Cloud. And so we can dispatch this job with this metadata once this job is created. Some implementation of this, we pretend that we're Circle CI so that we can see some nice CI features of Dagger Cloud because our toy CI, unfortunately, is not popular enough yet to be featured as a first-class CI platform. The image that's run for this Dagger job is we're actually using the same image as the engine because one, it has the Dagger CLI in it, which we need to run the pipeline, and two, it's already pulled on the agent, so we don't have to wait for a runtime to get pulled if it wasn't already fresh, right? So it's kind of a cool hack to prevent extra work because we've already got the image. Anyway, the entry point that we're going to say is we're running Dagger. And then something that we saw earlier was we ran Dagger call check locally. And when this is happening, you notice we're not checking out our code for this. What we can say for Dagger call is the module exists here. And so this is the same here as if I ran back on this terminal where we ran Dagger call check. If I said dagger-m github.com/kpenfound API at commit check call check. So this is basically what we're running in CI. So since we didn't have it locally, we can just point at that module remote at whatever commit we just received the event on. Anyway, we'll see how that gets wired through in a moment here. So we're calling the same function that we ran, which is check. And then it's sharing this bind mount with the Dagger engine, which we had just looked at. And that's how, again, I mentioned earlier that the job gets dispatched and it can point at its neighbor and say, the engine's right here, I want to run stuff on it. It's doing that by sharing this volume with the engine, essentially. And then we say if it fails, that's fine because it's a CI job and they fail sometimes. We don't have to retry it. It's kind of cool that we could build retry logic. If you have like flaky tests or something, you could say, yeah, like try it 3 times and then if it fails, it's really bad. But in this case, we're saying no to flaky tests. So we've got our 2 jobs that we just looked at. Now if we go over and look at Nomad, we can see both the jobs are registered. And then if we look at our project, remember we push to Git, and Git has a webhook that it pushes events to. And so if I go to the settings for my repo, and we go to webhooks, we've got a webhook configured at this URL. And we'll see this URL come up in a second. So this is the webhook URL, and let's go and make sure that that webhook is up and running for this. So we'll look at the code for the actual webhook listener in a sec, and that's in that same repo. But we're going to say we have this another Dagger function in the demo repo that is this webhook listener, and we're going to pass in the Dagger Cloud token, the GitHub webhook secret, our Nomad address, and our Nomad token. And that's going to run a webhook server on our machine. And then once that's running, we're actually going to tail scale funnel to that server so that it can be reached from the outside world over HTTPS. And so here's that endpoint that we saw was the same. If we pop over here, that Turkey beta, that's my tailnet name. I didn't choose it, but I kept it because it's great. And now this server is running on local 8080. We can look at what that webhook server looks like real quick, because it's kind of interesting. And so we have in our webhook listener directory in this demo repo, we have a Dagger module that's just a simple function called listen, and it takes in those parameters that we just saw in the command line. And then its function is to use a Golang Alpine container. It sets those environment variables that we passed in, and then we'll see the actual application it's running. But it's just a Golang container running our little Go app with 8080 and running as a service. So this is a way for us to like define the runtime for our little example app without having to worry about like the tool chain on my machine or anything. Like I don't need a specific version of Go on my computer. I can just run this webhook listener with Dagger, right? And so the thing that it's running is in the server directory, and it's just this little thing that uses this GitHub package and the Nomad API client. And with the GitHub package, it listens on this endpoint and receives those events from GitHub, looks at those events, and then says, if the event you received is a push event, as in like a git push, that's the only one we care about for our application. So if it was a push event, then let's call this function. Anything else, it just discards it, right? We don't care if someone like wrote a comment somewhere. We don't need to respond to that, but you could. So anyway, when we receive a push event, we're going to look at the payload for that event, and we're going to pull out the repo name and the commit ID. Because again, when we remember that Dagger call -m repo at commit, that's literally all the information we need to run CI to Dagger call check. And so we get that repo and commit, and remember these were the parameters for that batch job. And so it takes those parameters, and then using the Nomad client, it dispatches a job. And so this is running over here. We saw that happening. We see the server is started. So if we go back over here to our demo application, and now I'm going to say git push. So if we go back to GitHub, we have our little pull request open, and there's the commit we just pushed. And then we're going to see all the magic happening in real time. On our webhook listener, it dispatched the Nomad job. And then in Nomad, we're going to have to be really fast because it's a pretty quick CI job. We see one running job, and it's over here. And real quick before it's gone, we already missed it on Dagger Cloud. Here's the Dagger check. And it's done. So we're going to see the log output. And there's our test pass. So all of those crazy things connected. The demo gods were favorable, and we went from pushing a commit from GitHub through the webhook to this little Dagger function running in my machine through Tailscale to the Dagger function, and then from the Dagger function to Nomad, and then Nomad placed a job, and then that job ran Dagger-m, the repo at the commit call check, which was my commit that I had just pushed up here. And then that ran and reported itself back to Dagger Cloud so I could see my CI happening. And then when we look at our overview here, we can see all the stuff passing here. And actually, because I'm logged in locally, we can also see what myself and my friends are doing with Dagger locally, and we can see that webhook thing running locally too. So here's my webhook, here's my CI thing, and remember we were pretending to be Circle CI because our toy is not a fully featured CI platform apparently. We have our little Circle CI logo. Anyway, so that all worked out. Here's the demo repo. The slides are linked here too. And then if you want an easier way to get that demo repo, we can go over here and zoom way out here for you. And there is a Dagger module for creating QR codes. So I'm going to call it, it's at github.com/jpadams/QR. And the function is called generate ASCII QR. And the data is this URL. And so if I run this, It's going to load that module from GitHub. It's going to pass in the data that I wanted it to create a QR for. And then boom. And I'll leave that up for a sec because it definitely works. Let me verify that here. And there's my repo. Cool. So this QR will get you to the demo repo. And then real quick, I'll come back to it. Don't worry. But just to close out the slides, we're going to do another recap. I know I just recapped it. We did a git push. We made a change. We did a git push. GitHub got the commit. It sent a webhook to our endpoint. And that endpoint talked to Nomad and said, hey, we have a new event. You should dispatch a job. Nomad found a place in our cluster to dispatch the job to. And then that job started running. And that was Dagger. And Dagger pointed at the engine that was running right next to it and said, here's where the pipeline executes. And that pipeline orchestrated a series of containers within itself. And all those came together to finally say that the change I made to the README is allowed to be merged into our repos. We could close that PR now. And that's it. So again, you can check out the repo at github.com/kpenfound/hashitalks. Check out Nomad, check out Dagger, and here's that QR code again. So thanks for watching, and maybe, hopefully, you learned something cool about CI today.